In this video, we're going to be looking at the second derivatives of each of the following function. The second derivative is a very simple concept if you know how to derive. I'll just dive into it. Ne? Perfect. So let's start with the first one. On A, we are given g of x equals to 5x squared. So firstly, you need to do the first derivative. Ne? The first derivative, which is going to be this times that, which is 10. Then we can see that is going to be 2 minus 1, which is 1, right? So the second derivative is basically the derivative of the first derivative. So you are deriving twice, basically. So this answer, this is the first derivative, you are deriving it. So second derivative, you show it with 2 lines. Ne? Which is basically, we have 1 there, so 10 times 1 is 10. Then you're going to have x to the power 0, which basically just gives you 10, right? So that is the answer for the first question. That is the second derivative of g of x, which is 10. Then we have b. So we need to do the first derivative, which is, we can all see that is 8 times 3, which is 24. Then x squared minus 7, right? Then we need to do the second derivative, which is basically 2 dots, 2 lines, you can see that it's going to be 48x. Remember, the derivative of a constant is 0. So that disappears, right? Now let's go to C. On C, we firstly need to remove the brackets. Remember, I said before you differentiate, you don't need fractions, you don't need brackets, you don't need square roots. You just need terms, né? In the simplest form. So here you can see that we're going to multiply the x here and there. So which gives us f of x is equals to x squared minus 6x plus 10, right? You can see that f of x with a prime, which means the first derivative, is going to be 2x minus 6, because this is giving me 2x, this is giving me minus 6. The derivative of a constant is 0, so this guy will disappear. Now I need to derive again here, right? Which is the second derivative, so you put 2 lines, it will just be 2. Because this is a constant, it will disappear. Right. Perfect. So ladies and gents, now that you get the hang of it, I would advise you to basically pause this video and try the rest. And then proceed by watching if you went wrong or not. Ne? Please pause the video and try on your own and see if you really get the hang of the second derivative. It is a very simple concept. Okay, on D, right? On D, I'll just use a different notation so that you get to different notations. Ne? So I'll use dy. Remember, the derivative of y is basically dy with respect to x. Ne? So we say dy over dx, which we can all see that is 5x to the 4 minus 3x to the 2 plus 1. Remember, I said these videos are like a textbook. Ne? You need to start from the beginning and advance. So if you haven't watched the video on differentiation, please make sure that you do so first. Ne? I created playlist and all the videos are in ascending order from the easiest, the basic to the more advanced. Make sure you follow that. So if they give you in this notation and they want you to get the second derivative, this is how you write it. Ne? We say d squared y over dx squared. You need to know it. Once you see d squared y over dx squared, they just mean get the second derivative of y, which is basically 20x cubed minus 6x. And that finito with d. Now let's go to E. On E, we firstly need to simplify. K at x, I can see that, okay, I need to multiply the x squared then there. So it's going to give me x cubed minus x squared Then I need to multiply the 1 then there, which gives me plus x minus 1. And then there's no like term. So it's in simplified form now. So now I need to differentiate this. First derivative is going to be 3x squared minus 2x plus 1. Now I need to do the second derivative, which is 2 primes, which is 6x minus 2. Okay, perfect. Now we're going to do f and g. Let's do f and g. Okay, let me quickly erase here. Let me quickly erase here. Sure. So now let's go to f and g. On f, on f, we have p of x equals 2. We need to take the x squared up. Ne? So I'm going to have minus 10x to the negative 2. Remember, if it moves from the bottom to the top, it becomes a negative. Then now I can do the first derivative, which is 20x to the negative 3. Because this times that gives me 20. If I minus 1 here, I get negative 3. Then second derivative, this times that is going to be negative 60. And then x to the negative 4. And that is your answer for F. Now let's do G. On G, we have Q of x. We need to remove a square root. I remember I told you that the inside exponent is 1. The outside root is square. So it's 1 over 2 minus, plus 5x squared. Now let's do the first derivative of Q. So the first derivative of Q is going, remember here there's 1. So 1 times half is going to be half. Then we have x to the negative half because we're minusing a 1 there. Plus 10x to the power 1. Now let's do the second derivative. We can see that the second derivative is going to be this times that, which is negative 1 over 4. X is going to be negative 3 over 2 because we're minusing a 1 there. Then plus 10. Because here basically you have 1. So 1 times 10 is 10. Then you have x to the power 0, which disappears. Ne? Perfect. Now let's go to the next part. Okay. I'm going to skip 2 because it's more or less the same as what we've been doing. I just need to do 3 in this case. So you see here, d squared, x squared. This is like your y basically. So you're looking for the second derivative of that. Ne? So basically you're going to say y equals to 6 cube root of x squared, which means y equals to 6 x. Remember I said the inside goes to the top, the outside goes to the bottom. Then now we can start differentiating. First derivative, you're going to have 6 times that, which gives us, what is it? It's 4, I think. Because this is going to divide, giving me 2. Yeah, it's 4. Then you have x, you minus 1 there. It gives you negative 1 over 3. Right. Then we need the second derivative, which gives me this times that, which is negative 1 over 12 x to the power negative 4 over 3 because I minus 1 there. All right. And that's it about number 3. You can do number 2 if you want to. Let's do it quickly. F of x, we need to firstly FOIL, so it's going to be 10x squared plus 15x. Now let's do the first derivative quickly, which is 20x plus 15. The second derivative of f is 20. Right. Perfect. Now let's go here. On 4. On 4 basically is the same thing as what we've been doing, but here it's just too long because we need to firstly FOIL. Ne? Let's do that quickly. Y equals to 1 minus 2x 1 minus 2x, 1 minus 2x. I'm making 3 brackets because of that guy there. Okay. Then I'm going to firstly deal with these 2 brackets. Ne? I can see that those 2 brackets, if I were to FOIL them, I'm going to get 1 minus 4x plus 4x squared. That is what they will simplify to if you were to multiply them. But because you still have another bracket, you still keep this inside the bracket. Ne? Now I'm going to firstly multiply everything by this one. Let's see. So nothing changes because anything multiplied by 1 remains the same, right? Then now I'm going to do the same by negative 2x. This will give me minus 2x. This and that will give me plus 8x squared. This and that will give me minus 8x cubed. Now let's get like terms. 1 doesn't have a like term. This and that gives us minus 6x, which is this and that. This and that gives us plus 12x squared minus 8x cubed. Then once we are there, we can easily see that therefore g prime x, remember this is basically g of x, ne? This is y, which is g of x, right? So they want us to get the first derivative of that, which is simple. The derivative of a constant is 0. Here we get negative 6. Then here we get plus 24x. Let's make some space. Then we have minus 24x squared. That is the first derivative, right? Now let's do the second derivative. The second derivative, this is a constant, it disappears. Here we're left with 24 minus 48x, right? That is the second derivative. Then they say, what type of a graph is the first derivative? You can see that that is a parabola, right? How did I know that is a parabola? I saw with x squared. Ne? The highest degree is x squared. This one, it's a straight line. It's mx plus c. So it's a line, straight line. Right. Then they want us to get the value of second derivative. They replace the x with a half. So I'm going to replace this with a half and that with a half. So they need this. 24 minus 48. Where there's x, I put a half. Ne? And then I have 24 minus 24, which gives me 0. Right. Now they say, what do you observe about the degree or the highest power of each of the derived function? The highest power of each derived function is 1 less than the original function. For example, here the highest power was 3. Here the highest power is 2, which is 1 less. So the first derivative, it's an x squared, and then the function was x cubed. So which means the highest power of the derived function is 1 less than the original function. Thank you very much, ladies and gentlemen. If you found this video really helpful, don't forget to hit the subscribe button and share with family and friends, and leave a comment and like the video. Thank you very much. Aluta continua.